Hi everybody, welcome back. This is section 2 of chapter 10 on hurricanes and cyclones. And in this section we're going to actually look at what what kind of conditions cause each of those to form. Two different kinds of cyclones we're going to look at. By the way, a hurricane is a type of cyclone. But there's going to be two different types cyclones. One's going to be a tropical and one's going to be an extratropical. All right, these tropical ones are going to be the ones that actually turn into hurricanes and typhoons and the tropical storms that we hear about in the news. Extratropical hurricanes or cyclones, I'm going to give a different name to periodically. I'm going to call them mid-latitude cyclones, and we're actually going to do a diagram where I refer to it as that. So tropical means between 23.5 degrees and the equator. So basically straddling the equator on the north and south in the northern and southern hemisphere. But extratropical means as you get closer to the poles, or that is the mid-latitudes. In other words, it's where we live. So between roughly 30 and 70 degrees north and south latitude, that's the mid-latitude band. Okay? And so there's different kinds of storms, tropical and extratropical, or mid-latitude. They differ in a couple different ways. They differ in the characteristics, like how how strong the winds are and what kind of hazards they pose, and also development as well. We're going to spend some deal of time on the development of mid-latitude cyclones, so you'll actually be able to see a storm system come across the United States and actually know exactly what's happening as you see that pattern. So they mostly form, mature, and dissipate independently of each other. That is, they don't really affect each other very much. There's a few small exceptions. Actually, Sandy, Hurricane or Superstorm Sandy, Superstorm Sandy, I'm just going to abbreviate it, was one of those exceptions. Back in the 90s, there was a movie in the late 90s called The Perfect Storm. And in the early 90s, it was based on an actual storm that was a hurricane that became an extratropical cyclone. But those are actually very rare cases. Usually they form independently of each other. All right, and so what tends to happen is, I mentioned how some can transform into extratropical cyclones, but usually they don't. Usually what happens is when a hurricane, this is the, let's see, did I do that right? I didn't draw that right. I'm trying to draw a hurricane symbol, and there we go, like that. That's a hurricane symbol, and it's actually rotating the wrong way, but when that moves up towards colder waters, cooler seawater, remember, it's the warm water and warm air that actually feeds these storms, and when it goes over cooler water, they tend to break down and fall apart. So usually when they move up into the mid-latitudes, they don't retain their organization, but they break down. But with the exception of Sandy and the Perfect Storm back in the 90s, there are a few exceptions. So a tropical cyclone, that is like a hurricane that you're used to hearing about in the news, is basically a large complex of thunderstorms that happens to be in a circle. All right, they rotate around an area of low pressure. We're going to see how low pressure areas cause air to rise up, and we've actually seen that to some degree already. But they start rotating because of the Coriolis effect. All right, and all this is formed because of warm ocean water. If you don't have warm ocean water, you don't have the fuel to cause tropical cyclones or hurricanes. And so based on where they originate, they go by a couple of different names. We talked about how they can be called typhoons, right? Typhoons, they can be called cyclones. They can be called hurricanes. But these are actually the highest end, the most powerful of these storms. There's other names too, like tropical storms and tropical depressions that are kind of like the building up to hurricanes. All right, so smallish storm, and as they get more organized, they get different names. And so where they form is they're going to be given, and how they form are going to be given different names. Let's look real quick though at where you can expect hurricanes and tropical cyclones to form. Anywhere there's warm seawater. All right, now most of them that come up our coast come up kind of like, or come into our area, come up in that sort of a pattern right there. And so they form right here off of Africa. You can see that in the the western Pacific, there's lots of even warmer water, and so there's tons of cyclones and typhoons that come through there. A lot of them kind of blast through Indonesia right here, and some of them come up through and graze Japan. All right, but these right here, the ones that we care about, the ones that affect us, usually originate off of Africa, off of the west coast of Africa. Okay, so remember how I said they have different names based on their stage of organization? Well, the lowest stage is called a tropical disturbance. All right, and this is usually what starts off of the coast of Africa. Africa is very warm, and so if you get this big blob of really warm air breaking off the continent out into the ocean, it's going to start rising and causing the humidity in it to condense. All right, so they're usually not all that big, 200 to 600 kilometers in diameter. It's like a big mass of thunderstorms, and they don't last usually all that long. But if they do, they can start to get more and more organized. They have a little bit of rotation because of the Coriolis effect, and we tend to call these troughs wherever you have an area of low pressure. All right, remember we have these lines called isobars, right? Well, wherever there is like a dip in it, kind of like that right there, if we're looking down on it from overhead, that would be an area of low pressure. That area of low pressure is causing that trough right there. This would be an area of high pressure right here. It's called a ridge. In fact, I should draw that in blue because high pressure is usually different temperature, different air temperature. So, but anyway, we call these troughs right here. Wherever you have an area of low pressure, also known as a trough, that's where you can have a tropical disturbance starting to form. All right. So, this is the beginning of what we would eventually call a hurricane. This right here is a line of thunderstorms. You can see those very flat-topped cumulonimbus clouds right there. Now you can see this is over land, and so it's not over the water, but that's the kind of system you would expect to see as a tropical disturbance. All right, this sort of elongated mass of low pressure air rising up and condensing. You can see it right there, and so that could be the beginning of what we would call what could eventually become a hurricane. Okay, but if it doesn't break apart, if it doesn't kind of die down after 24 hours, if it continues to build, the next stage would be what we would call a tropical depression. All right, now I think I mentioned this before, but depression we usually associate with kind of like a state of, a mental state of a person, but the depression in this case is with regards to the air pressure. Right? Low pressure, so we call it a general depression. You might say it's a depression in those isobars, right, where we have that trough right there. So what we usually see here is that a definite center of low pressure is formed. So we have these clouds that are kind of starting to circulate right there, and in the center, they're just kind of circulating around like that. All right, there's a definite low pressure center, not like this elongated thing like a tropical a disturbance, but really a tropical depression. That is a low center of pressure right there. All right, as it continues to organize itself, now there's no particular eye quite just yet, like in a hurricane, but as it gets more and more organized and there's more rotation, this kind of counterclockwise rotation right there, and as wind speeds increase, it eventually becomes known as a tropical storm. All right, a tropical storm is usually either depression or a storm is where they usually are given a name. All right, in accordance with the list of names that that is produced every year. So, like Hurricane Katrina was Tropical Storm Katrina at one time. It was probably Tropical Depression Katrina at one time as well. But of course, it built up to that very powerful hurricane state. So tropical storms have even greater wind speed. All right, and in fact, I think. Well, it's definitely given a name in tropical storm. I think in some cases they're even given a name in as tropical depressions too, as depending on how powerful it is. But they're definitely given names in tropical storms right here. This is the stage right before it becomes a hurricane or a cyclone or a typhoon. So the wind speeds aren't quite there yet, but it does have a lot of intense rainfall. Okay, so finally, after the tropical storm continues to build, and if it has that warm ocean water as fuel, it eventually organizes itself into a hurricane. All right, and a hurricane, of course, many of us think of a hurricane as having an eye. They don't always have an eye, but many of them do. All right, and that means it's very, very well organized. And we'll look at kind of how that eye forms a little bit later. All right. Once a tropical storm's wind speed exceeds 74 miles per hour, that is, if it reaches 75 miles per hour, 75 mph, then it becomes known as a hurricane. Okay, it has to be sustained. That means it can't just be a gust of 75 miles per hour. But if you've got consistent wind speeds of 75 miles per hour or more, it's called a hurricane at that point. All right, the ocean water is very warm. All right, so here's your water right here, and there's a lot of warm water at the surface. All right, so that's all warm right there. What's that warm water do? It causes warm air to rise up. All right, and this is all this warm air right here that that is fueling that hurricane, that is condensing and causing the release of latent energy, which or latent heat, I'm sorry, which produces the winds. Okay. As you go up, all right, as you go up in the atmosphere, it gets colder and colder and colder. We call that a temperature gradient. It gets colder. That is, the hurricane isn't colder, but the atmosphere itself is colder and colder because so you have a blob of air rising up, okay, and then it condenses. I keep writing in red. I should really do it in blue. You got warm air right there. I'll change it into like a light blue. All right, it condenses into a cloud. All right, if that cloud is still warmer than the surrounding air, it's going to continue to rise up and rise up and rise up. And so as long as the atmosphere is colder as you go up in altitude, then that means the condensing water vapor is going to continue to rise and rise and rise because it's warmer than the surrounding atmosphere. Okay? Now remember that hurricanes are really nothing more than big donut-shaped bands of cumulonimbus clouds. Air rising is going to produce that tall cloud, and that's what we see when we look down at a hurricane. We see these bands of rain. And do I have the right color? Yeah. All right. So let's see. It looks kind of like a saw wheel right here. Okay. And there's the eye that we're so used to seeing. All these bands are really nothing more than bands of cumulonimbus clouds that happen to be rotating because of the Coriolis effect. All right. In our hemisphere, they rotate inwards and counterclockwise. It's not a very good arrow right there. All right. But this is what produces the heavy rain and the winds that does so much destruction. All right, and then there's the eye wall. Right, what the eye wall is the area. I'll draw this in, let's say, darker blue, I think. All right, it's the area right around the eye. Okay, now you probably know the eye to be the calm area in the middle, but it's kind of ironic. Right around the eye is the most powerful part of the storm. That's where the wind speeds are the greatest. That's where the rainfall is heaviest. And as you go towards the center, it gets more and more and more extreme until you're at the eye wall where it's the most extreme. And then, strange as it may seem, you get inside the eye wall and then it's as peaceful as can be. So once you're inside the eye wall, you're in the eye. Now, a lot of times people will say, well, the eye of the hurricane is the most dangerous part. Well, you can't get into the eye. It's actually not true. The eye is calm, but you can't get into the eye without going through the eye wall because it's a circle. So it's the most dangerous part, or it's the calmest part surrounded by the most dangerous part. And so you can't get into the calm without going through the danger. So these are the three main parts of a hurricane. The rain bands, that is the big arms that stick out in all directions, the eye wall, which is right around the eye, and then of course the eye itself. So here we are actually inside the eye, taken from a plane right here. And you can see this kind of, it looks almost like a stadium, this big bank of clouds going, this big semicircle going partially around us. In fact, if we were to be able to look all the way around, we would see it go all the way around us. All right? It's not perfectly all the way down to the ground. Oops, I want to go back. It's not perfectly clear all the way down to the ground. There may be some clouds right there, but as you go down, it's not stormy there at all. They're just kind of like gentle clouds, because what's happening here is air is sinking. It's rising all up around. It's rising up here and here and here and here and here and all around us in the eye wall, but the eye itself has sinking air. You know that as air sinks, it dries out. And so that's why the eye is very oftentimes clear, or mostly clear. Right here is kind of just sort of a 3D computer model of Hurricane Katrina, and what you have here is, they call them hot towers. That is these pillars of rising warm air up and up and up. And this is just one of the rain bands of Hurricane Katrina. But as they continue to rise, because the surrounding atmosphere is colder, you continue to have water condensing and latent heat released, and all that energy is able to be put into very, very high winds. Okay, so how does wind actually, or how does air move in and around a hurricane? Well, you probably know that air has to rise up to cool and condense, but it doesn't just rise, but it rises and swirls. It swirls because of the Coriolis effect. All right, so it spirals up around the eye wall, or around the eye of the hurricane, and of course, and this is the big thing right here, this is why we talked about latent heat. As air condenses from a gas into a liquid, latent heat is released. All right, that latent heat, that energy is released, that is released from that phase change right there. That energy goes into the high winds that we know are true of a hurricane. All right, and in the next diagram, I'm going to sort of show you how the air kind of swirls up right here. But as air rises up in and around the eye, well, dry air in the center sinks back down in the middle. All right, and so as long as there is warm water underneath, it's going to rise up, cool and condense, and then the drier air is going to sink back down. And I'll show you in this next slide right here. Okay, so we have this kind of swirling action. This is sort of a cutaway view, all right, but you can see, look, there's a cumulonimbus cloud band. There's another cloud, cumulonimbus cloud. These are all bands of cumulonimbus clouds kind of swirling around in a central around a central low pressure area right there. And as they rise up, air cools and condenses and rains, and you high winds because of the release of latent heat. But air is rising up in a counterclockwise motion as it condenses. But then the drier air is able to sink back down into the middle. All right. So if you get all this air rising up, it's got to be replaced by something. All right. And so air is able to sink back down in the middle and then be brought back up again. All right, so the hurricanes are actually very complex. This is kind of an oversimplification of it right here, but this is the general idea behind how winds flow in and around a hurricane. All right, so we didn't spend much time, at least at the time of this recording, we didn't spend much time yet talking about different types of global winds. But really, it's depending on what wind belt you are in on the Earth, will determine kind of the movement or the direction of hurricanes. I'm going to go, let's see, back to this map right here of the Northern Hemisphere. Okay. So real briefly, I'll give you kind of a crash course in wind belts. Between the equator, which is right here, and about 30 degrees north latitude, so 10, 20, 30, it's 30 right here. Not a very good arc, but you get the idea. We have winds tend to be moving kind of from the east, kind of from the northeast to the southwest. All right, and they're called the trade winds, Trade winds. These are directly related to the pressure belts that are around the Earth. We did talk about how at the equator, it's the equatorial low pressure zone. All right, and at about 30 degrees north latitude, it's the subtropical high pressure zone, right, where you have all these deserts right here. Well, anyway, between these two zones, you have winds flowing. All right, so they're called the trade winds from about 30 degrees latitude down to the equator in both hemispheres. Let's see, I'll do a different color for the next one. From about 30 degrees north up to about 60 degrees north, we have what's called the westerlies. Now, winds are based on where they come from, not where they're going. And so these are basically coming out of the west or kind of from the southwest. All right, and so these are called the westerlies. Also, westerlies, also caused by those pressure belts. Lastly, and this is these don't affect us very much, but all the way up the poles, I'll do this in green, they kind of come from the east again. They kind of swirl around the poles. We call them the polar easterlies. Okay, easterlies, because they come from the east. They don't affect us very much, but look, between the trade winds here and the westerlies right here, I'm going to pick a different color. I'll do yellow. All right, we have a track that basically steers hurricanes. They come across the Atlantic right here, and they move a little bit north, and then they get caught in the westerlies, and they get blown back that way. So many hurricanes, east to west, west to east, east to west, west to east, take that track as they approach our continent. And it's because of those two main wind belts, the trade winds and the prevailing westerlies. Which, by the way, is why most of our weather, as we live in this area right here, most of our weather comes from the west because of the westerlies. Like I said, that's what causes this track. All right, as they move from east to west, they're in what we call the trade winds. But as they move a little bit north, they get caught in that belt called the westerlies that most of our weather comes from, and they get blown back from west to east. And so we can have a number of different tracks, but thousands and thousands of hurricanes over the past century have taken this any one of these tracks right here as they approach our continent. And that, for now, is going to be it for this section of notes. There still is a little bit more of section 2, but what I'm going to do is for extratropical cyclones, that is for mid-latitude cyclones, I'm going to do a separate video. And there's also going to be a diagram as well that we're going to sort of mark up. But that'll be a separate video. So for the time being, for now, that's it. Thank you for following along, and if you have any questions, make sure you come and see me, and we'll clear them up. Thanks for watching, and I'll see you on the next one.